Now we look at what we call relative velocity. So that's the velocity of object A with respect to object B. So let's consider that you're at the airport and you see this platform, the moving platforms, which take people normally in a straight line. And let's suppose that this platform is moving with the speed of 3 meters per second in the, let's say that's the positive x direction, and that's the y direction. So y is not upwards, but it's along the ground. And you have person A over here, and A is standing on that platform. So A would be moving with the platform, but he's stationary, he's not walking. And then we have, let's say, B, and B is in a bit of a hurry, so he's moving at a speed of 2 meters per second on the platform, so he's walking on it. And there's a person C standing outside, and he's also just standing. So now when C looks at A, C will see that A is moving to the right at 3 meters per second because he's standing on the platform and the platform is moving at 3 meters per second. And C will, when C looks at B, B will appear to be going really fast, and B will appear to be having a speed of 3 plus 2, which is 5 meters per second. So B, the speed of B will be the sum of his own speed plus the speed of the platform. Now we can use the notation that V A B will be the speed of A relative to B, or it's the speed of A as seen by B. So B will see the speed of A as VAB. And similarly, VBA will be the speed of B as seen by A. So with this notation, the first term being the speed of the object and the second being as seen by or relative to the second one. So if we use this notation, then we can say that V of A as seen by C is going to be 3 meters per second. The speed of B as seen by C is 5. And the speed of B as seen by A is 2 meters per second. And we can also say that the speed of C as seen by A will be minus 3 meters per second, because A is stationary on his own platform. The platform is moving to the right, so it will appear as if C is going backwards, and therefore VC of A becomes minus 3. Now with this, we can also say that was A and B, and the whole platform was moving at 3 meters per second. That was 2, and C was here. V of B with respect to C is going to be the speed of B with respect to the platform, or with respect to A, plus the speed of A with respect to C. So of B with respect to A was 2, and A with respect to C was 3, and we got the value of 5. So we have this equation that we use to add the velocities, and that is the Galilean transformation equation. Now let's do an example. Let's suppose we have a river, and the river is moving to the right. with a speed of, the river is moving to the right with a speed of 3 meters per second. And there's a boat over here. And the boat is pointing straight towards the opposite direction. So as the boat starts moving, the river is flowing to the right. It will cause the boat to move at an angle, and it will reach here. So if it leaves from A, it wants to reach B, but it will actually reach C because the river is going to push the boat to the right. Now the question is, if we know the width of the river, which is, let's say, 100 meters, and the speed of the boat is, let's say, 5 meters per second. So the speed of the boat with respect to the water is 5, and it's in the, let's say that's the x and the y direction, so it's going to be 5j. The speed of the river with respect to the earth is 3 meters per second, and that's in the I direction. So what is the speed of the boat with respect to the earth? And that's going to be just the sum of these two. So it's going to be the river, the boat with respect to the river plus the river with respect to the earth. So it's going to be 5I, sorry, it's going to be 3I plus 5j. So it's going to move 5 meters in this direction in 1 second and 3 meters in this direction. This is with the river, and that's by the engine of the car, the boat. Now with this we can find easily how far it's going to go. We can use the equation xf equals xi plus vit plus half at square, and there is no acceleration in the x direction, and we can take this as the origin of the coordinates. So x initial can be taken as 0. This would be x final, and v in the I direction, so vix, speed in the x direction is 3t. So that is going to be xf, but we don't know t. The t is the time it takes for the boat to go from A to B. So for that we use the y equation. And this is 0, there's no acceleration of the river, and this is going to be y initial is 0. We can take this as y initial is 0, and viy is going to be 5j, and t, and this is 100. That's the width of the river, that's 100, and therefore t is going to be 20 seconds. We can plug that t in here, and so xf is going to be 3 times 20, 60 meters. So this distance is going to be 60 meters. This distance is 100 meters. We could also get that from trigonometry. If you have 5 here and this is 3, so if 5 becomes 100, 3 becomes 60. We can also use that to find this angle. Now, a somewhat more interesting example would be, which we will leave for you to solve, is that if the boat does want to go from A to B, so the boat should actually start off at some angle. The river is going this way. So what should be this angle theta? So that as it goes this way, the river pushes it to the right, ultimately it goes straight. So what would be that angle? We'll just say that this angle is theta, this angle is theta, and let's call this angle phi. Then phi is not equal to theta. So the two angles would be different. So you can take the same numbers. You can take the same numbers. This would be 3 meters per second. This would be 5 meters per second. So what is the value of the angle, and how long would it take? And would it take the same amount of time to go from A to B as it did to go from A to C? Okay, so try those.